Welcome to my educational video on molecular geometry. My name is Lillian Freeman, and today I will be discussing the linear molecular geometry. This sort of molecular geometry consists of two regions. There are no lone pairs in this setup of atoms. Linear molecular geometry looks like this. As you can see here, this consists of two atoms bonded to a central atom. These bonds are spaced 180 degrees apart, making it symmetrical down the middle. This is as far away that these atoms can get from each other in 3D space without getting too close to each other again. These geometries can be seen in equations written in the form AB with a 2 subscript. We will be using a carbon dioxide molecule as an example. To start, you must make a Lewis dot structure. The Lewis dot structure will look like this. The carbon atom is sandwiched between two oxygen atoms because the carbon is less electronegative than oxygen. To determine the polarity of a molecule, you must first determine the polarity between the bonds of each atom. Using the electronegativity number found in electronegativity periodic table, you can determine the bond type between each atom. In this case, because of the math, you will find that the bond between the oxygen and the carbon atom is both polar bonds. To determine this, you would subtract the electronegativity number of carbon from the electronegativity number of oxygen. This polarity can be seen by showing the delta plus and delta minus signs. These delta plus and delta minus signs note partially positive and partially negative molecules and which molecule is more or less electronegative. As you can see here, these arrows go in opposite directions, denoting that this is not a dipole. Because these arrows go in opposite directions, this means that this molecule as a whole is nonpolar. If they were going in the same direction, this molecule would be polar. I hope this video has been helpful to you as we have discussed linear molecular geometry.